All right, let's try this again with a shared screen. We had a aborted attempt at this video already. How do I know this first reaction is a Claisen reaction? It's a Claisen condensation. Well, two molecules coming together to make a beta keto thioester. Fact is, there's a ketone beta to this carbonyl is a giveaway for a Claisen, any kind of ester. In biochemistry, I want you to actually take a look at what CoA looks like. It's not trivial, but you're going to see it in so many courses. It's not funny once you leave this class. So we should know what acetyl-CoA is, and it looks like this. That is acetyl-CoA. This is a fatty acid already, and it's going to grow to a bigger fatty acid when we're done. This one will have a double bond in it, be an unsaturated fatty acid. It's the ester form of a fatty acid. But anyway, we're doing a Claisen. We got to figure out what alpha H to take. And clearly it looks like this thing lost its leaving group. There's no S-CoA on the carbonyl that has the N, CH2N. So it left, which means it got attacked by an anion on this carbon. What base are we going to use in biochemistry? Well, we're going to use the base that's attached to some active site in an enzyme. Hey, we got an enzyme with a lone pair that's going to act like a base. Right here. Red first. Okay, ignore me. Red first. Blue second. We'll find a way to get purple in there, I hope. Although these don't look like big mechanisms. Might not need purple. It's okay. We're going to grab that H and make an anion. Now you can't two-step this one because if you put a lone pair on that carbon, some of you have tried this on previous tests. I write OV-1. You can't have a lone pair on that carbon before the H is taken off. So you can't draw an H on that carbon. Oh, sorry, you can't draw a lone pair on that carbon until you draw the product, which you must draw. And we'll have it in green. S-CoA. Lone pair. Anion. Nucleophile. The broken record strikes again. Attack, pi breaks. This oxygen has lone pairs already, so you can two-step it. Bring back one of those lone pairs and kick off your lovely leaving group. S-CoA minus. And it says S-CoA minus becomes HS-CoA. Hey, let's use purple while we're here. Lone pair already on S. Grab an H from H enzyme. Oh yeah, the conjugate acid. So we've used the enzyme as a catalyst, huh? I really hope you're not surprised to hear those words. Enzymes are catalysts. You've made the product. And unlike in lecture, or if we were doing this in the lab, you would generate a base that's strong enough to take this H off. We did not, in biochemistry, generate a base strong enough to take that H off. S-CoA minus, even if I didn't protonate it, was not a strong enough base to grab that H. So you don't have to do the second Claisen step, which is deprotonation of that double alpha position. You don't have to do it. In this one, you can go straight to your product. Isn't that nice? This is the NADH2 molecule. This is the time to learn about it. Previously would have been a nice time too. Might have got you some bonus points on other exams. What's happening? Please realize that this is a CH2. How do we know that's important in this mechanism? Well, it's not a CH2 when you're done. It's a C with one H when you're done. We're going to take that and resonate this way and this way. Or we're going to use this and attack something with it and resonate from the lone pair here and then there, and that's going to be an attacker. Depends on our needs. And our needs are for a new H to attack the carbonyl. There it is. New H on the carbonyl. Make it look more like an H. I don't know what it looks like. Well, you're hearing me say it. It's an H. So, yeah. Lone pair on nitrogen resonates in. Keep that resonance going. And then H minus attacks carbonyl. You get O minus. It doesn't look like the steps are separated like we normally have to do in other reductions. So lone pair on O is going to grab H in blue. H enzyme seems primed and ready to go. There you go. Done. No intermediates. Got every product indicated here and here. And what's going on here? Ladies and gentlemen, please realize you're losing an alpha H. I better not draw it over my reagents because I'm pretty sure I need them. Can I get rid of my new H from the previous reaction? Because it's stick figures and I don't need it anymore. And now I'm going to draw the H that needs to be removed. There's two H's on that carbon right now. In the end, there's only one H on the same alpha carbon. Notice this carbon is now this carbon. Going to remove the H, make a pi, leaving group leaves. How do you make an OH leave? Even in biochemistry, typically you've got to protonate it first. And then you take with a base the beta hydrogen. Beta. Alpha's got the leaving group. Beta's one away. This is a classic E2. In blue. End of story. Next one, we're going to do 2E when we come back. This is how you make fatty acid. This is real biochemistry, how you make an unsaturated fatty acid. Don't you find that interesting? They don't grow on trees. Actually, they do, because trees have the metabolism to make unsaturated fatty acid. That was a joke, and it was also serious. See you.
Okay.
Very soon.